Okay, it's time to start a new topic, and we're going to look at the world of algebra. Now this topic has no limits, and so I will restrict it more to material that's covered in the GCSEs that are sat commonly in the UK, but lots of it is applicable across the whole spectrum. So let's start with a typical situation. What do those add up to make? Now some of you will have gone 9 add 9 is 18, 27, 36, 45 and so on. How did the rest of you do it? Did any of you go, there are 10 of them, so it's 90? Well, you've recognised that adding on repeatedly is the same as multiplication. You've recognised that 9 add 9 add 9, 4, 5, 6, 7, 8, 9, 10 times is the same as that. That's a very basic but very important piece of algebra. So let's use it in an algebra context. I'm going to use the letter x, a curled x. Why is it curled? Well, if it was a straight x, it would look like a multiply sign. We use an x for a number which is unknown. And it comes from a Greek word which corresponded to traveller or unknown person. So, what do you get when you add the following? You're going to say to me, 10 lots of x. And you'd be right. The problem is, how do you actually show this? Because this here is quite dangerous. What happens if you've got scruffy handwriting? Is that 10xx? Is that 10xx? Is that 10xx? Now, using x for an unknown value is a standard convention in algebra. It's not a rule, but it's a thing that we do a lot. So therefore, we're going to stick with the curly x for unknown. So we have to resolve this issue. We can't just ignore it and use a instead. So, here is the solution. We're going to write 10x. And when we write two things next to each other, like this, or A, B, to mean two different letters, we mean 10 multiplied by x, or A multiplied by B, or three multiplied by x multiplied by y. So, we avoid multiply in algebra if we can. It's almost our first little rule. Okay, let's get back to where we were. What does that make? How else could you write it? Well, there are 3 of them. You want to say 3 lots of x. You can't write multiply because we avoid multiplying algebra. So we write 3x. This side here is simpler. In fact, we call this process simplifying. A lot like we simplify fractions. Let's have a look at a little bit more simplifying. I've got a number, I add the same number again, I add the same number again, and I add the same number again. So at this point, what have I got? At this point, I've got 4a. Then I take off a. What happens next? Well, let's have a look at this pair. Adding and subtracting are inverse operations. They are opposites. They cancel each other out. So if I add 2 and I take away 2, that cancels out. So when I add a and I subtract a, that cancels out. So what am I left with? I'm left with 3a. Let's try another one. What do I have here? Well, I've got a plus another a. What do I then have here? A plus another a plus another a. Take away a single a. It doesn't say take away 1a. We say banana, 1 banana. We say 2 bananas. So I like to think of this as the singular, and when you put a number in the front, it means you have more than 1. Let's get back to this. I've got 2 at the front here, plus another 3. That makes 5. Good. One of those is cancelled out by the takeaway or the subtract. So that leaves me with 4a. Can you see how I step this out? Some of you will be looking at it going, 2a add 3a makes 5a. Take away another a makes 4a. So you will see this line here straight from there. That's perfectly okay, as I'll show you now. (5a) add 3a is 8a. Take away 2a leaves me 6a. By now you're starting to feel confident on this, I hope. But notice we've only dealt with these 2 operations. In the next part of the video, we're going to look at simplifying where we have more than one letter. So more than one number that we don't know. So we're going to look at questions like, how do we simplify that?